Our lead-off presentation is by Paul Yarin. Yarin, I'm sorry, Paul, I never figured out how to pronounce your name. So when you get up,
Yarin is fine.
Yarin, okay.
Yeah. Yeah.
He's a mechanical engineer. He's a clean energy advocate. He's chair of the Foster, New Jersey Environmental Commission. And his home is heating with circulating water through radiators. There's a bunch of us, and it's a significant number that are heated with water through. And now, as they upgrade their home, like Paul, you're going to go to a hybrid air to water heat pump. And he's talking about a brand new model designed with people actually willing to come on the show and talk to us for more information. Anyway, so for listeners with a hydronic heating system, Paul has the electrification solution for you, and he'll talk about his techniques to find the best operating point to minimize his greenhouse gas emissions. So you're going to learn about his system control and monitoring platform. And so Paul, just take it away.
Okay, very good. Let me make sure these slides are working. You can see a title slide there, I hope.
We're waiting for it, but it's coming. There we
There
go.
we go.
Okay. All right. So thanks everybody for being here. I lead the Environmental Commission in Closter, but I am speaking as an individual, as a homeowner, and not as officially the positions of the commission. I mention that because I'm going to mention some companies and we have conflict of interest policies. So I don't want to be seen as part of my government role representing them. I've worked in technology development at startups and big companies for most of my career. I am not working in this industry at all. This is all out of my interest in energy and environmental advocacy. So the story I'm going to tell you is not about a perfect passive house or a net zero home, but a real world story of trying to implement electrification in a progressive manner that I hope will give you some ideas. I'm hoping to connect the concept of hydronic heat pumps, intelligent controls, and the possibility that, as Steve was alluding to, we can have a more intelligent and informed interaction with the grid than we have in the past. So the outline of my talk is that I'll start with explaining why I think it matters to New Jersey to electrify homes that have radiators. Then I'll go through my own weatherization project and what it achieved. I'll cover the hybrid heat pump retrofit and what I installed, why I went this way, and how well it worked. And then I'll shift to talking about my own personal experimentation with something called Home Assistant and the control layer, which is about dashboards and diagnostics. But what it really is about is trying to give you some insight as to how your system is working and enable you to make better timing decisions in the future. I think that this then leads to how a flexible electric home can help serve the grid, even if you don't have a large home battery. Okay, so why do buildings matter in New Jersey? They matter because after transportation, which is about, I think, 38% of carbon emissions in New Jersey, they are the second biggest category. In the New Jersey Comprehensive Climate Action Plan, there are targets based on a baseline in 2022 of about 25 million metric tons of carbon dioxide from buildings in New Jersey. And there's quite a radical shift required to get down to less than 5 million metric tons. I mean, an 82% reduction. Um, so this means that whatever electrification pathways we take and decarbonization paths, they have to work for a wide range of homes, and there have to be solutions for all of them. And I guess in New Jersey, about a quarter of the homes use either steam or hot water to circulate heat throughout the house, and that's close to 1 million homes. It's a significant part of the electrification challenge to address homes that have hydronic heating. By the way, steam is basically going out of style, and so the vast majority of those are hot water circulation, not steam. There are still some holdovers that use steam, and I'm talking primarily here, by the way, about single-family detached homes, although a lot of the technology also can apply to multifamily structures and larger buildings. Okay, so here is my house, and it is in Bergen County, which is in the northeastern corner of the state. It was built in the 1950s, and a previous owner expanded it considerably in the 1990s. We took it in the 2010s, about 10 years ago. It has five bedrooms and 3.5 baths, 3,000 square feet, so a large-ish house or mid to large-ish house. In our town, we get gas from a different utility from PSE&G than we get electricity from. So it's a little bit confused how they both have independent incentives and weatherization programs and so forth. Uh, ORU, you may not be familiar with it if you live in the center of the state or in the south part, but it's sort of just the northeastern corner of New Jersey. It's largely in New York State that Orange and Rockland Electric serves. In our area in northeastern New Jersey, it's called RECO, Rockland Electric Company for short. Okay, so in my house, there's a gas boiler, which you see at the left, one of those small images. Let's see if I can point at it here. Um, it was, provided in the 1990s, so it's, 30 something years old, and it's serving 6 hydronic zones. That is independent sets of radiators in the house through independent circulation pipes. There's a mixture of older base ray and newer slant fin radiators at baseboards around the house. There is also an indirect water storage tank, which is this. It's called indirect because one loop of very hot water heats up the water without touching it directly. There's a heat exchanger inside of it. And here you see an example of a slant fin aluminum radiator. And then there's an air conditioning unit, which we did not touch as part of this project. And while we're not talking about EVs here, primarily, I wanted to just mention that I'm a big proponent of EVs and have been driving them for something like 15 years. But we don't have solar in the house because there's heavy shading in the over the roof, so it doesn't really work for this house. Otherwise, solar would be an excellent complement to all the stuff we're talking about here. So the first stage in this kind of project for electrification that's recommended is generally weatherization. You want to make your house as efficient as possible through inspection and then sealing. So we contracted Seal Power to do an energy audit where they did a really thorough job of crawling around through all of the nooks and crannies of the house and measuring the thickness of insulation, looking for the quality of the seals, using a thermal camera to detect drafts, assessing all of the equipment in the home. How old is it? How efficient is it? What's its performance rating? And based on that, they projected an energy savings through a weatherization project of 32%. A couple of years later, due to COVID and some other unrelated delays, we actually did this project, and the same contractor did the work. It was a pretty major and impressive project, especially pulling all of the aluminum siding off of the house to blow insulation into the walls. That is not minimally invasive surgery. And then they also added insulation inside of the attic and put panel insulation in the crawl space and so on. Ultimately, it scores on the Pearl certification, which is one of many different kind of environmental ratings, silver, and that's a certificate you can then pass if you sell your house to another homeowner so that they have some accreditation that you've accomplished this high efficiency home. The cost was about $19,000. $5,000 were offset by, and I think it's high performance weatherization energy savings incentive. Now it's something called, I think, whole home performance. Maybe someone can comment on that, but it's a similar program where the utility gives you 0% financing for the cost of that effort, and instead you pay for it with no large upfront capital expense, but a surcharge on your monthly gas bills for that period of time. So I'm paying an extra $100 or so on every gas bill to pay off this investment in the weatherization. The weatherization really worked. So we went from about 1,450 therms a year. So this is a measure of natural gas consumption to about 1,050. So indeed, about a 30% reduction. Note that this does not reflect the savings that you would also get in the summertime from reduced air conditioning costs and air conditioning energy use, right? So maybe 32% is probably accurate, or maybe even understating the actual energy savings. So you want to weatherize before you do other things, typically, depending on how modern your house is, especially for an older house that's drafty or has leaks. So the hydronic heat pump is a new thing on the market. Well, it's not entirely new. The Department of Energy, or EPA, did some challenges to the industry 7 or 8 years ago. And a few, I would say, somewhat specialized companies have been in the market selling to sort of very um, adventurous homeowners. But Weil McLean is a major national boiler manufacturer that every plumber knows. So it is a new thing for a mainstream player like that to bring in a product like a hydronic heat pump. So, as with an air-to-air heat pump, this air-to-water heat pump has a very similar, if not identical, outdoor unit that exchanges with the warm or cold air outside and circulates a refrigerant inside. I think it's R290, one of the newer refrigerants. But what's different is that instead of having an air-to-air heat exchanger inside where you then get forced air blown through ducts in your house, or if you use a mini split, no duct, but the mini split indoor heat exchanger is right on your wall. Instead, you go to this thing called an indoor unit, which is integrates it's sort of the other no, I'm sorry, it's the part that actually heats the water for you, and it works in concert with a boiler, which could be a Weil McLean boiler. I don't think it absolutely has to be though. And it works with your existing water heater. So the advantage is you now have two different options for how you can heat your house, electricity or gas. And the choice of which one to do is not totally obvious, and we'll get into that. But so anyway, I did not opt for the sort of more modern and efficient modulating condensing boilers. Those of you who are into this I don't know how much detail to go into this. Maybe I'll save it for the Q&A. But basically, it would have required some modifications for the house that were not easy to make. Let's see, did I cover this? And just want to point out that the indirect water heater is on this chart as well as you can also get hybrid water heaters or heat pump water heaters, but you don't need to in this case because the heat pump is serving that purpose. Okay, so a little technical data here. I used CoolCalc to do a manual J calculation, which is basically you measure the walls and you figure out how much exposure there is and how much heat loss, and it tabulates that data. That was part of what was needed for a rebate application, but is also useful for sizing the system. But the most important thing here, I think, is on this top right chart, you're seeing the switchover temperature between at how cold do you want the heat pump to be running? I'm sorry, at which temperature do you want to switch between the heat pump and a traditional gas boiler? So the lower you make that set point, the more work you're doing through electricity and the less you're using gas, which has the effect of reducing your natural gas consumption by up to 130 million BTUs in my case, but also costing you more money. And so obviously these are based on the prices that were a certain moment in time. The electricity prices have been dynamic, gas prices are also dynamic. So it may not be quite as simple as what you see here, but the point is that you have to choose a switchover temperature and express that if you want to qualify for a rebate, because they have to believe that your energy model is realistic. Um, and because ORU and most of the utilities have never seen these things before, we had to do a custom rebate that was a new kind of decarbonization rebate of about $300 per million BTU of gas not consumed, right? So it really is based on your actual decarbonization performance, and they verify that after a year with your gas bills and measurements. So in the end, I spent about $28,000 on the installation and all the equipment and got a rebate of about $7,000 back from ORU. I want to just thank Residential Air Systems, Steve Hernandez, Weil McLean, Conrad Wittick, Bill Edelman, and the people from Orange Rockland Electric, Kyle Haddock and Christina Mariscal, who all worked with me on a somewhat confusing and convoluted project. Finding an installer was not trivial. They say not all heroes wear capes. Well, that's Steve Hernandez wearing a very comfortable cotton hoodie. And he was really the champion here because he was the only one out of many, many HVAC installers who spent a lot of time on my property who was willing to do this installation. And he just buckled down and read all the manuals and figured it out. So I really, really appreciate that. Um, and they're out of Cedar Grove. Okay, again, not my formal position. I just want you to know this was a good experience. Um, so the installation was first just the boiler. So in this large picture at the bottom, you can see the boiler is this box over here. And there was an issue with the availability of the crew, which was excellent, but at the beginning, it was November and it was getting cold, so we just replaced the boiler at first, and then a couple of weeks later, did the rest of it. So during that time, he prefabricated this large panel, which has all of this equipment. So what you see here is the heat pump indoor unit. That's this big gray box. Two zone controllers, which are basically the control electronics to switch on and off these circulator pumps and valves, which circulate the water through these seven zones, which are six heating zones, and then to the hot water tank is one of the zones as well. And you can see these copper pipes snaking up, which go all around the house and serve the water to the rest of the house. So the install was done very efficiently, a total of about 3 days on site, including some time for tweaking the software. Okay, so this brings me to once it was installed, it was nice and warm, but I didn't know what was going on, and I was very curious. Is the heat pump running? I kept going down into the basement and trying to look at it and trying to decipher what its status was. So I eventually learned about this platform, which I am recommending to anybody who's interested in sort of hacking in the energy space. It's a low-cost computer similar to a Raspberry Pi that sits in your utility closet and provides home automation. It's an open source project from a community of people who contribute software for free. It is not tied to any big tech walled garden or rules. There's an amazing number of things you can connect to it and integrate with it, and I'll get into that. You can build your own dashboards and you can figure out what's really going on in your system. Okay, so this is probably the nerdiest part of this, but it runs 24/7, so you want it to be very low power, which it is, and it can connect to a wide range of different home automation protocols and wireless protocols. You can use it through a web browser or a phone app, and you can program it to operate on a schedule or based on your behavior, like who's in which room, or you could have it sense when you get home. You could make it react to your calendar, all those kinds of things. Um, a few things that I thought are just kind of interesting that I never would have expected going in. First of all, I did not know that all the gas meters in my neighborhood are transmitting their gas consumption constantly, wirelessly, unencrypted all the time. And so I can easily pick up like dozens of neighbors' gas meters just by putting a cheap antenna out. And of course, I'm not trying to surveil them, but I thought that was kind of notable. I think that used to be true or more true of electric meters, but they've locked those down. But gas meters are still pretty much open. The Modbus protocol is worth getting into if you're going to control industrial devices like these, and I found it to be fairly straightforward. This device doesn't have Bluetooth. Okay, PJM Data Miner 2 is this is the way that you can get data about the grid's current performance on 5-minute intervals. And this is really interesting, and we'll get into it some more. But there's a free API you can sign up for. If you sign a few legal documents, you can get access to this. And I also just want to say that this new world of coding LLMs has been transformative to me as a very mediocre coder myself. They are amazing at helping you do at least basic things very quickly. So out of the box, the Home Assistance dashboard is already pretty neat. And let's see, how are we on time? I guess if we feel we have the time, I'll do a quick live demo, but I don't want to push the time too far. I've got I think you know where I am in my slides.
I
Uh,
think we're okay if you
okay,
want
all right.
to
Let
do
me
whatever you want to do.
okay. I will switch quickly to another window here if I can figure this out here. Um, okay, let's try to. I hope that this is clear. You can see a web browser with some buttons on it. Yes, okay, great, thank you. Okay, let's start with the energy dashboard I was just referring to. So this is oops, all right. So this is a out of the box stock dashboard. Due to something about the screen sharing, I am having trouble finding the controls that I normally see. So okay, I'm just going to talk at a high level then. Normally, you can scale this between different periods of time. So you can, but here you're seeing an actual entire year, $4,000 of energy costs from everything. And this chunky data back here is because I decided to populate with my old gas bills before I had this automation. I just wanted to have some data there so that I could do some math on the results. So that's what that is. This dashboard here is one that I built, which shows you whether the heat pump is active or not at this very moment and how much electricity your whole house is using, which right now is kind of significant. And this is like literally right now, this is what's going on. One thing that I think is interesting for many people is you can see how much you spend on electricity today and how much you spend on gas today. You know, these are things you don't normally get to monitor in real time. And it just it changed my psychology a bit to be able to say, oh, okay, I've spent about $11 on electricity today. It kind of puts it in perspective of other things. So I'll show you a more complex dashboard that I built to monitor specifically the Weil-McLean equipment. And I realize this is probably confusing. I will zoom in a little bit. But using the Modbus control, so this is through integration with Google. These are actual live buttons. So if I want to turn on the heat to a certain part of the house, right, I can go there and, oops, again, because of my screen sharing. Oh, there it is. Okay. Um, I can actually turn these things on and you will see them. You will see this turn red hopefully in a second. Yeah, there we go. So these are the calls for heat from around your house, okay, in real time. This is the indoor unit and the return and supply are the temperature of the water that's going out of it and at what temperature, usually lower, it's coming back. This is the outdoor unit, which is active right now. Good timing, running at 46 hertz, and the fan is at a certain speed, and you can see exactly how much power it's drawing. And also, it has a nice ambient temperature sensor for the outdoors. So, anyway, I don't know. I'm not sure that will interest everybody, but it is interesting that you can get all this data, and the switchover temperature down here is related to when it's cold outside, you actually need a higher temperature in your radiators to keep your room equally warm. And so, in general, these kinds of control systems have a curve that looks like this kind of a shape where it transitions between two set points. And so you can see right now we're at the warmer end of this spectrum here. Um, I'll show you one more, which very quickly, and because it will lead into what we're going to talk about next. So let's see here. To make this less confusing, let me turn off some of these markers. So this is that outdoor temperature sensor and what it's measuring over the last 30 days. Okay, and we can change that, let's say, to 7 days. Oops, but by doing so, I turned on all these things again. Okay, let's look at 7 days. The next thing here is this is how much electricity I used over that period. And you can see there's some periodicity to it. And here's the gas that was used over that period. And finally, at the bottom, what's going to appear is the PJM carbon intensity of the grid at those periods. Okay, so this is for every kilowatt hour of electricity you pull down from their grid, what is kicking on to serve that capacity, right, as measured by the PJM for that particular, it's called a P node. And it varies a fair amount, and more than I would have expected. So at certain moments, certain times, it's cleaner and certain times it's dirtier. And so what I tried to do then is add a graph of, okay, how much electricity, if you multiply the kilowatt hours I'm drawing from how clean or dirty the grid was, what's my actual carbon impact from this electricity use? And how does that compare to my actual gas usage, which more directly translates into carbon? And finally, if you sum the two, you get a kind of total carbon impact of your home. I realize that's a lot to go through, but all of these numbers are relevant if you're trying to find the right optimal balance between comfort, cost, and carbon. Okay, I'm going to switch back now to PowerPoint, hopefully. All right. So this was, I didn't think I'd have time for a live demo, but that was basically telling a similar story about how these controls are dynamic. And I guess the point is that the grid is clean at different times of day, and it's not what I expected. What I expected is that at night, when demand is generally low, the grid would be cleanest. But in fact, perhaps because of a lot of solar or some solar that's been added to the PJM grid, there are certain hours between 4 and 6 that were cleaner. And in general, some of these daytime hours were cleaner than others. I don't know all of the reasons for this, but I'm trusting that the PJM data is accurate. And I guess the point here is that being off peak doesn't mean that you're low carbon. So ultimately, you really want some kind of a real-time grid signal that is very specific to your location and the particular configuration of the grid at this moment to draw from. And of course, this is from the consumer's perspective or from the environmental advocate perspective of either saving money or saving carbon. The utility has its own incentives as well to save money and to maintain reliability commitments. So it's actually overall a rather complex problem that I think the next speaker will get into. But another point I want to make is that your house, even if you don't have an electrical battery there or an EV, to some degree, the thermal capacity of your house is a shiftable load. So you can sort of charge up your house by heating it up and then let it coast by letting it slowly cool off, right? So if, I haven't figured this all out yet, but there could be an algorithm whereby you use energy during the moments when the grid is cleanest to you know heat up your house, and then you let it coast during the periods when you think it's going to be dirty. And I just think that's very interesting because you don't have to buy batteries in order to make that work. You do need some intelligence in the control system, but it doesn't necessarily mean you have to buy a large piece of hardware. So I'm calling that shift without shopping. So, to summarize what we talked about here, I think that there's a path for electrification for hydronic homes where you reuse radiators and pipes and maybe even your gas boiler. Um, there is also an opportunity to use intelligent controls for this shifting of loads and demands and to optimize between comfort, cost, and carbon, and also peak demand, which is a concern of the utility in terms of building out the infrastructure. Um, I would also say the state of this is pretty early and a little frustrating, in that I don't think most consumers are probably aware of this, which is partly why I wanted to talk about this. And so they're not creating a lot of demand for installers, and the installers tend to like to stick to proven technology and proven approaches. I think that utilities are aware and they're trying to plan for the future, but at least for the hydronic heat pump story, that is still a very novel concept, even for utilities. And if we don't actually get all of these parties in line, or if we don't all collectively accelerate our efforts, we're not going to meet these aggressive decarbonization targets. So I will take some questions, but I hope this leads up into Mike Winka's presentation. I'm eager to hear about virtual power plants, and I'll just put my contact information up there, and let's do some Q&A. Thank you.
Paul, there's only one question in the chat at this point.
Okay.
And Jeff says, did you say your energy costs for the year were $4,000 with this new system? How does that compare with your cost before the change?
That's a good question, and I don't have an accurate answer to give you right now. I wish I should have prepared that. But in general, I don't think I'm saving a lot right now, but I'm also in an experimentation mode. I'm trying a lot of things and have been I've been driving the electric heat pump as hard as it will travel. Um, I guess in general, to answer that question, you'd want to know the coefficient of performance of the heat pump and the uh, cost of electricity versus the cost of gas, or the effective BTUs delivered per dollar of electricity or gas, right? So I think the potential is there for savings depending on how you dial in the heat pump. And please go ahead, Jeff, if you I see you popped up there. So
Yeah, sure. So I really liked your idea of the shift without shopping. I think that's what you called it, right? And it reminded me of something where I happen to be living, which is in Healdsburg, California, quite a different climate area. It's very
mhm,
hot in the summer and very cool at night. It's almost like a desert kind of climate. And we have an energy recovery ventilation system.
mhm, mhm,
And what I would like to see, and as far as I know, this product doesn't exist, is I would like that system to be able to pull air in without doing the energy recovery at night. So cooling down my apartment. And then during the day, I wanted to shift back to energy recovery ventilation to keep it cool. Have you ever
mhm.
heard of such a product?
I've well, I'm not intimately familiar, but I see articles about things like that: thermal storage through ice, thermal storage through other media, concrete blocks. I think in desert climates, I think there's been some experimentation in that. Of course, those media have a lot more thermal capacity per volume or per per room in your house than air. So that might make sense. I think I've heard of some startups doing things like this too, but I don't have enough to tell you there. I do think there's a lot of room for this kind of innovation, but at the same time, I mean, it's all a question of how quickly these things can get to market level scale, right? Like, startups are great, and I've been in startups too, but this is a numbers game. We need big numbers, and so hopefully our government will have the wisdom to fund the scaling of the technologies that have the potential to do ERV or things like that, as you say. But I would keep my eyes open for anything that's starting to come onto the market, and I'd encourage you to try it, right? Because I mean, that's what I'm trying to do is to try to see does it really work? And I wouldn't be giving this talk if this didn't work, right? I wouldn't want to push it on anybody, but it does seem to work. That said, we have to qualify it to a greater degree. And your question about the overall cost is very relevant for most people. So let me work on answering that for you.
I have another question. Bob asked, why did you not use the AC ducts and an air-to-air heat pump?
Yeah, that's a good question. I still may actually. It is possible to do both in parallel. But again, partly, as I said to Jeff, I wanted to try this newly available technology and see if it really is relevant. Now, that said, there are some pros and cons. So, apart from reusing the existing heat pipes, I guess well, I've heard that some people I've installed mini splits before, air source, air to air heat pumps, not in this house, but in another place. Some people don't like the forced air, the feeling of forced air, just blowing on their face, basically, where you don't really have that with radiators. Some people don't like noise. I like quiet. So, radiators tend to be very quiet, and circulating water tends to be very quiet, or at least a kind of pleasing stream-like white noise a little bit in the background. Um, but you're right. We could, and that might be the next project if save up some money and try the air-to-air heat pump. But I do think it's interesting to see how they compare, and I guess if we had both, maybe we could do a direct comparison. Hope that answers your question.
I have another question from David. Is there any way to make use of the cooling capability of the heat pump in summer? Maybe you just haven't gotten there yet.
Yeah, that's a good question. I have heard of people doing this, but my intuition is that it wouldn't be highly effective. It would probably, you're right. It does have the capability of running just as with an air-to-air heat pump uh, bidirectionally, right? Reverse valves and so on. So you would essentially have these ice cold kind of, well, not ice cold literally, but fairly cold water pipes in your room during the heat of summer, and the idea would be they would be absorbing some heat from the air around them. Um, I don't know. We'll see. But I'm not really counting on it yet. I think probably upgrading my very old air conditioner would be a smart move for that reason.
I have one more question and then we'll go on to Mike. Jesse asks, out of curiosity, do you have an AHRI certification for the installed Weil-McLean system? You may not have it offhand, but I would be able to share it with, or would you be able to share it with me in the future?
So I don't know this in detail, but this is a document that is a sort of official performance characterization by AHRI. So it's sort of like a statement. It's sort of a white a cut sheet that says a bunch of technical specs. Is that correct? If so, I'm sure we can get it from Weil McLean. I'd be happy to get it to you if you can just send me a quick email or something, and I will ask Weil McLean for it. I'm in close touch with them.
Yeah, Jesse, if you want to answer, you can come off mute. Okay, there are, oh, wait, there's something here from Jesse. Oh, the number is kind of like a tracking number, he says.
Oh, okay, okay. So it's a document reference, it sounds like, into a database of other. I bet there is something like that, but I don't know, and I will have to research it and get back to you if you don't mind just dropping me a note. I can't see the chat myself right now, so
No, I'm just reading it. And I'm going to stop there. There are a couple more questions, but we'll
perfect.
have, after Mike's talk, you can ask questions about either speaker.
Okay, thank you so much. Thanks for the good questions.
Thank you. That was great. Steve, you're on mute.
Okay, a quick confession. I'm embarrassed because you're so automated. And I personally have been running around my house for the last 3 or 4 years, measuring in all different aspects, trying to find the optimum operating point for my house, which has uh, two gas furnaces and one heat pump. And I try to use the heat pump as much as possible. I'm trying to find the optimum point for it. So, so I wish I had an automated system like you. I was, using paper and pencil, writing down all the measurements and doing calculations, etc. But thank you very much for your talk. Next, we have a very distinguished speaker, Mike Winka. He's the retired director of the BPU Clean Energy Program. He knows our technology like the back of his hand, and he knows the important people and has been through his career of dealing with New Jersey government. So Mike will present the past, present, and future of distributed energy, distributed demand response, and virtual power plants. And he's going to present an overview tonight showing how the many pieces have to fit together. At that point, I'm going to put a plug in for our next webinar, which will be on April 16th. It will cover all this in detail. We have at least one uh, supplier of virtual power plants that wants to get into the New Jersey market. I spoke to them and they have been waiting as other states have had virtual power plants, and they're the leading vendor right now, and they're eager to get here in with us in New Jersey. So anyway, Mike, it's up to you.
Great. So can you see my presentation,
Yes,
right?
we can see it.
Okay. Great presentation, Paul. Fantastic stuff. And that's what we need more of, is people taking the opportunity to reduce their carbon emissions and doing that with some technology. I'm going to talk about virtual power plants. A sort of diagram on the left-hand side is what the grid looks like. Centralized power plants to a transformer, to the transmission system, to the distribution system, to your house, to your load. And some of us have been dreaming about these things, virtual power plants, for about 25 years. I'll talk about, I'm going to keep this at a pretty high level because Pat and Steve are lining up speakers that actually do run virtual power plants and get into more of the details. So I'm going to keep this pretty high level. Virtual power plants 101, the basics. I'll lay out some terms. So when you start talking about these things, you'll know what people are talking about. I'd like to do that in 101 discussions. tell you where they came from, what's changing, what changed, and what's up for next steps. So these are the definitions. I'm not going to go through any of them. These are the terms you'll see when you start talking about virtual power plants. They're not legal definitions. I just did a Google, chat, hey, fill in this definition. That definition in the middle, distributed energy resources, DERs, that's the key. So you can have a definition for DERs that includes everything that's above here. Energy efficiency, demand response, demand flexibility, EVs. The program for virtual power plants or distributed energy resources depend on how you define in that program the DERs. Does it just include demand response? Does it include energy efficiency? Is it only EVs? Is it behind the meter solar? Is it all of the above? That technology helps you define what the virtual power plant can do. And then below that is all the sort of communication software, the protocols, the sort of policies that allow the communication. And virtual power plants are combining the communication to the technology to let you get access to the grid. And it's all under the rubric of grid modernization. You'll hear that term, or integrated distribution planning, IDP. So you can look at those terms later. I won't go through them, but those are the key sort of definitions when you talk about VPPs. So where did VPPs come from? Demand response. Utilities have run demand response programs for decades, since the 1990s. Utilities had radio control on your central air conditioner. It was basically a one-way control. BPU had an order back in 2008 that said utilities have to run these programs. PJM has been running demand response programs for larger customers who can shift their load, move a shift over here or move a process over here and move their load, and they get paid for doing that, and they're delivered by curtailment service providers, and they've been doing that for decades too. The management system was called the Distributed Resource Management System, DRMs. It was basically a one-way communication limited to not so smart thermostats. And electricity usage, why these programs didn't really take off is because electricity usage for about the past 15 years has been pretty flat. That diagram on the right-hand side, if you look at it, that's the electricity usage in New Jersey on an annual basis since 1960 to 2022. You can see from 1960 to 1980, electricity usage doubled. And from 1980 to about 2020, it was on track to double again. But you'll see about 2007, the load sort of flattened out. A lot of things behind that. Industry in New Jersey sort of shifted, load shifted. We had more energy efficiency. We had a statewide program. You had solar, and the grid sees solar on your roof like you're shutting off your lights. Even though it's generation, it is lowering the demand on the grid. And you had all of those things come together, more building codes, electrical standards, so load was reduced. So what has changed to allow VPPs to move along? Smart meters and smart grids and microgrids that were being rolled out, mainly in response to Irene and Sandy. If you can remember what happened during Irene and Sandy, we didn't know what part of the grid was operating that would still go out and check what's down. Well, smart meters allow you to do that, and smart grid allows you to understand what's down at the very minute. And there was a big push from the federal government after Sandy to do smart grid and to do smart meters. The state started looking at microgrids. You had islands of power that were running after Sandy, during Sandy, like Princeton University got to operate when all around them were down. Rider University, Rutgers University, even down in Salem Community College, hospitals. So that's sort of the technology that's put together, but a microgrid is basically just a small grid with its infrastructure. The communication started to take off. It's called Zigbee. You can see the definition in those terms. Led to interoperability standards in IEEE 2030, that whole series in UL 1547. So those standards started to develop, and that technology got better and smaller and faster. we came up with smart inverters. So inverters right now are pretty unsmart. They're just called grid following inverters. They just put voltage on the wire at the frequency. These new smart inverters let you play with frequency and voltage and VARs and all the ancillary services. So they're called grid forming inverters. And that allows you to participate from the very distributive level into the grid level. And costs got lower. I mean, costs for solar 20, 25 years ago was $12, $15 a watt. Energy efficiency of the efficiency of the panels were about 6-8%. They're now, you can get them for $1 a watt or less. Efficiency is above 22%. So batteries and EVs are getting cheaper and getting more access. And the monitoring system for all this changed. It changed to a two-way conversation called DERMS, Distributed Energy Resource Monitoring System. You can read the definition of what it is, but it allows the utility to communicate back and forth, not just this one-way signal of electricity coming into your house. It allowed you to have this conversation back and forth. And now, as we all know, with data centers, peak is up. So one of the things that's changed. So where are we going today? In New Jersey, the utilities have pilot programs for demand response programs as part of their Triennium 2 energy efficiency program. So Triennium, they just approve programs on 3-year cycles, so they're called trienniums. So that's just the state utilities energy efficiency programs. RICO, JCP&L, ACE, and PSE&G all have sort of bring your own device, basically smart thermostats that allow that signal to go back and forth, and they pay for some of that demand response. So they're all basically bring your own device, sort of home optimization, direct load control. PSE&G has a small battery program that they're setting up to allow this two-way conversation with that storage from your solar system. But these are small numbers. They're tens of thousands of participants, kW's worth of load control. We need tens of thousands, hundreds of thousands of participants and megawatts worth of load control. And that's where the program's going. So Governor Sherrill's Executive Order 2 says within 180 days, BPU has to develop a VPP program with the utilities and third-party aggregators based on the existing programs that the utilities have, both on the large size and the smaller system, and to develop the rules to implement FERC Order 2222. So this is the FERC Order 2222 is the rules that say, hey, you got to allow solar, distributed solar, batteries to play in the marketplace and set up that program. So on the utility side with third-party aggregators, they can play on the system. And then there is Senate Bill S3399, which is a VPP bill to reduce peak load introduced by Senators Winka. And we'll see where that goes. So just closing, just a couple more slides. So that thing on the left, that's the PJM Management Control Center. Every time you flip on a light, they know where a generator is flipping on. You saw in Paul's presentation, the emissions from the grid at various times is up or down because they're bringing in generators and they're moving generators around and generators are shutting off. That thing on the right-hand side, look at those boxes. Every one of those boxes, think about as a generator. And those generators are connected to the transmission system, which is managed by PJM. They don't own the transmission system or the generators. They just manage that flow of electricity. And that upper picture in the middle, that's all the utilities. PJM is not a membership of states. It's a membership of utilities. And utilities go across state lines. So you see all those utilities. And those utilities are the aggregators, the connectors between the generators and PJM and your load being distributed and used. Now think of the system, those little boxes, as your house, your solar system on your house, the EV that's sitting in your driveway, the heating system that Paul put in with the load controls that he has, smart appliances, demand response, grid flexibility, grid interactive efficient buildings. And all of those things together can be managed by an operator that's on that left-hand side. And that could be PJM, could be the utilities, could be something separate. You want something that's independent, just like PJM. PJM doesn't care what the generators are on this side or the transmission company or who owns them. They just manage that flow. So that's part of the key of this system. How do you manage that? It's definitely going to have to be the utilities in some degree because they manage the system. And the key point is who's that aggregator? Is it part with the utilities? Is it part third-party suppliers? Is it all third-party suppliers? Those are the rules that have to be figured out. Just to highlight those rules on PJM's capacity market, their rules are 300 pages long just to play in the capacity market. So there is this thing that's coming, but you're going to have to set up the process to be able to do that. Just again, just a couple of more slides to close. We're taking all those technologies that you see on the right-hand side, EVs, load management, CHP, solar EVs, connecting that with the bottom left-hand side, the communication down to the meter on your house, and being able to play moving electrons onto the bulk grid system. So I've been talking about this as the future for clean energy, but I see this as the future for energy. Integrated, holistic system that you can upgrade your building, just like Paul said, with building shell measures and insulation, weatherization, electrify your home with heat pumps and induction stoves, and upgrade your ride with EVs and EV charging, and power your home with and your EVs with solar and battery storage. But you can also then manage your home with smart appliances and chargers, just like Paul talked about, that system that allows you to do that and be able to participate in the grid and send your stored energy into a grid as part of a power plant. And what's needed is the same thing we did through 2000, deregulated the industry from a vertically integrated system to an open market system, and that's energy deregulation 2.0. And so just quickly talk about the benefits. So, it's adding capacity, can add capacity quickly, gigawatts nationwide without big siting requirements or permitting issues. It's economic efficiency. It delivers value by the marketplace, but you need those rules to set that up. It's energy efficient. It's a better use of all those components that we've been putting in our homes and on our homes and in our driveways. And it's a better understanding of the energy system. It's more democratic. It allows everybody to participate in the system. It's just not, hey, I plug my system in and I get my energy from the grid and that's magic. Well, this allows you to participate in that system. And even though I said it's the future of the energy system, it's a lot cleaner. With the same reliability, the same resiliency and affordability, but there are costs. So nothing comes without cost. And when you tell the utilities to do something, they're going to say yes, but we want to be able to recover our cost and we want to be able to make a profit. So those are the things that have to happen. And you'll see as BPU rolls out VPP over the next couple of months, you'll see how that rolls. So with that, Paul and I will take some questions if there are any.
That was perfect. Thank you. Thank you, Mike. There's really only one question left over from Paul's talk. Both Jeff and Orion asked about condensation on your system, on the pipes or anywhere else in your system. And that's for Paul. And you're on mute.
Yeah, I think they're referring to, now that I can see the chat, the condensate from a ModCon boiler. So
Yes.
a ModCon boiler recovers some of the heat that would normally go up your chimney as hot air with a secondary loop. And so you have this lower temperature gas, which then can't power up a high chimney in the same manner and generally goes through horizontal pipes to a penetration in the wall of your house. So there is some condensate of water. That water is, yes, that has to be managed. It has to be collected into a drain pipe, basically. So I think that answered the question. But But that said, it's not that it's impractical for New Jersey. Many people do it. In my particular house, the penetrations to the outside of the house weren't in good locations for basically they're too near where people sit. There's like a little patio I have in the backyard, and there wasn't really a great way to run that. Also, the cost of the boiler was much higher. Um, so that's why we didn't do it.
Thanks. There's another question for you, Paul, before we go on. And this one, there are two Jeffs asking questions, by the way.
Okay.
This is Jeff C. The upfront costs for the hydroponic electrification are high. I would think the X factor to an elevated cost benefit would be solar. The side of the equation would provide free electric costs when the sun is available. Um, Otherwise, I would think that this investment might not be cost justified. And I know you said that you really didn't have a suitable roof for solar. And I would add that most people here probably know that Steve and I have the same situation, and we use community solar. Um, so you can answer that question.
Yeah, no, I think Jeff is right. Solar would be a wonderful addition. It's so frustrating that I can't do it at this house. I'm actually trying to do community solar with the Environmental Commission in the town, converting a site to that. But as to the bigger question of like, will this be cost effective? It's complicated because, as we all know, energy costs are offset by a variety of incentives, which keep popping in and then disappearing and getting reversed, and so it depends to some degree, as with electric vehicles, on that environment, the incentive environment. I don't know, maybe Mike has thoughts on that or knows what's coming, but I don't think that it's. Look, I mean, somehow society has to bear the cost of the carbon we're putting into the atmosphere, right? There are many ways to measure and to characterize the social cost of carbon. This is one where you actually have control of it in your own house, right? I like the idea that I don't have to depend on anybody else to reduce my carbon usage. I can just do it myself. I'm not disagreeing with you, Jeff. You may be right that solar may be the missing link to make it really cost effective, but I do think there's an argument nevertheless to try to do this kind of thing.
Let me switch to the other Jeff, Jeff P., who has his hand up.
Yeah, so I just want to clarify, as Frank H. noted in the chat, actually what we were referring to was whether the hydroponic system could be used for cooling with the heat pump. And the issue there was condensation in all these pipes that you have running all over your house, especially in a humid climate like you have in New Jersey. Seems like it would be difficult.
Good question. Haven't got there yet. Would love to report back when we have a summer with this, and we'll see.
Okay, thanks. There are some more questions in the chat. Bob asks, how soon can we use EV? And this is a question for Mike. How soon can we use EV for VPP/DR in New Jersey? Is there an actual timeline in New Jersey?
So Executive Order 2 says BPU has to come up with a program in 180 days. So you'll see that. I doubt that says you can then turn on your EV and send things into the grid. FERC Order 2222, they're also doing in their grid mod. So they're working with the utilities to figure out all of these things about what happens if there needs to be curtailment and you were guaranteed a payment, who gets paid for that. You want to work out those rules before something financially happens that you complain about. So you want all those things to be worked out. So it's probably going to be a while, even though a lot of us are pushing the BPU to move faster. There are, up in New England, they're allowing distributive energy to play in the marketplace, distributive solar to play in the marketplace. And you saw that over last summer actually lowered some of the demand curves up in New England. So that's coming. And just on the incentive that Paul raised, I mean, that's because the BPU manages that budget, and that budget has to be approved. And something comes along like the affordability issue of rates rising, So that puts downward pressure on how much money can be available. What we like is putting that in the marketplace. SRECs were in the marketplace. It didn't change because this governor came in or that governor liked it or didn't like it. Once you set the rules up and they play in the marketplace where you get your money from the competitive market, that's a lot harder to, things tend to stay a little stable, although market prices can go all over the place too. So it allows you to do that.
I think demand response includes having control over the wall connector for your Tesla or the charger.
Yep.
PSEG has that ability now. JCP&L is promising that to me 4 months ago, but I have not yet seen it.
Yeah. So they all have programs that allow that to occur, and again, mostly on the smart thermostat side, but there is some load control. PSE&G has their program running, pay for performance to reduce load, and it doesn't matter where that comes from, whether that's a battery or solar or your EV that's sitting there. So you can go to PSE&G if you're in their territory, go to their program, and you can see I think it's home optimization program, but I could be wrong.
Mike, this is an easy one from you. I know you know this answer. G. Tish, I think that's not his real name. Says, when I put in solar a few years ago, I was limited to what my house uses in a year. Why can't I put more solar and generate on the grid?
Well, so you can now. So they changed the rules. You can export only what your historic usage is. But the rules now are changed so that you can start to put more solar on your roof, non-exporting solar. So again, the economics are you're not getting the avoided cost of retail. You can do that for, charging your batteries or whatever. But that's the first step in setting up this structure for VPPs. So. But again, you can only export your up to your historic usage. And then when your historic usage changes, if you have extra solar on your roof, you can start to export that. So.
Okay, now I don't exactly remember what this refers to, but Frank is asking, is saying they may have been referring to try to use the baseboard heaters to cool the home.
Yeah, I think we covered that. It was the word condensate that I misunderstood the meaning of the question, but I think we covered that.
Oh, okay. That is the end of the questions, unless someone has another one that they'd like to make.
Well, I want to thank Mike. If somebody wants to put a question in, they can. I would like to give you notice that Sunrun has the majority market share now, I think, for both solar installations and battery installation, and is now aiming for that majority for virtual power plants. So we'll have them on the show next April 16th, and you'll get to hear firsthand what they're trying to do in New Jersey. We'll probably have other vendors as well at that time as well. I wanted to do a little commercial. We have around New Jersey, we planted knowledgeable trained coaches to help New Jersey residents plan to electrify their home. And those coaches eagerly wait the chance to help you. It's really easy to sign up. I'm putting in chat an intake form that we use. So if you're interested, just fill it out and send it in, and we'll see if we can assign a coach to somebody near you.
Okay, that just popped up in the chat. And
Great.
Jeff has his hand up again, so let's.
Yeah, if I may add my own sort of ad. Third Act has just started. They're just about to kick off a new campaign, which they're calling Solar Advocates. And the idea of this is to have volunteers work with a couple of Third Act partners. Greenlight America is one of them, that can help funnel local support for solar community scale and utility scale solar projects in an area, in a neighborhood. So the idea is they find a project that needs some support, they will send that message to people who are local to that area, who will then go to, board of supervisors meetings and whatnot. So you can sign up or find out more about that through Third Act if you'd like. Thanks.
And Bob Wilson has his hand up.
Yes, Paul. Should I be charging my Tesla on sunny days rather than overnight?
Well, I think, I don't know that I've had enough time with the grid data to be confident that whatever I see can be extrapolated to anybody else or any other region. I'm looking at one P node in the grid. Maybe Mike can tell us exactly what that means, but
That's strange to me because mostly nuclear, at least in New Jersey, but I'm not sure about you. So you're up in Rockland
Yes,
territory,
very
so I'm
far
not sure
north.
you don't have Indian Point, so maybe it's not nuclear.
Right.
There's might be some low cost coal that's running there that runs, base load at night. That might be the reason that you're seeing that, but most of New Jersey is running nuclear during the overnight hours, so that's basically zero
I
carbon emissions.
I don't
But
think, yeah, New Jersey doesn't have any coal that I know of, both plants. And
no, but
I,
PJM does, so it
PJM
all
does.
oh, do
depends.
they?
You're
PJM.
In New
still,
Jersey?
oh yeah,
Yeah.
yeah,
Oh,
not in New Jersey, right? But we're all connected in
we're all
PJM, so
connected, yes.
you're getting whatever. And in Rockland, you're more connected to New York independent system operator. So
Right.
they have that flow from the north down to New Jersey. So that's strange to me. I like to
If
look at the data.
I think a general point, though, is that eh, this is not easy to figure out, even if you're spending a bunch of time building these dashboards and things. And I don't know if I should complain about that or not, because I'm not sure that most people want to go to this. I think that if the utilities published a simpler price signal, right, that just said we're going to dynamically change. So rather than a time of use rate that's just, at night or day. So Michael, maybe you have some thoughts on that.
Yeah, so there are, I I thought Atlantic City Electric has a time of use pilot program. So they are looking, so BPU in this whole VPP grid mod is looking at the different rate structures that are out there and seeing, a lot of pilot programs across the states are looking at time of use rates, letting electric vehicles, which puts demand pressure down on the grid, charging at night instead of. But you raised a great question. What is that emissions during the nighttime? So. But I charging your EV with your solar is probably the way to go. So right.
Yeah.
Amazing. You get away from using gasoline and you use your own fuel, and once
it's
your
all
system's
clean,
paid off,
yeah.
it's free fuel, right?
I think Bob has something else to say.
No, I was just going to say, well, we don't have enough solar that we have spare during the year. So,
Well,
maybe
you
I
have
should
to,
in the summertime when it's sunny, and if the air conditioners aren't running too much, charge my Tesla in the daytime. Otherwise, I'll do it at night.
you can install more solar in order to sell it now, if you have room.
We have trees to the south.
Don't cut trees down.
Okay, all right. It's
About 8:15.
8:14.
So I
thank
thank
you all
everybody
for
for joining
coming.
us. And if you're interested in a lot more information about virtual power plants, you will hear it in 1 month. So I'm stopping the recording.
Thank you,
See
everybody.
you later, guys.
Have
Thank you.
a good night.
Great presentation, Paul. Good
Thank
job.
you, Michael. Same to you, and let's stay in touch.